Hello students, this is my third lecture in Fourier series. In the previous lecture, we have discussed about the German form of Fourier series expansion and the Fourier series expansion of discontinuous function. In today's lecture, we will discuss about Fourier series expansion of even function or odd function. Okay, so let's start today's lecture. So first of all, we will discuss about even function and odd function. So, what is the definition of even function? A function f of x is said to be even if your f of minus x is actually equals to f of x. For example, if you take cos of x, okay, so it is actually f of x. Now, if you find f of minus x, so f of minus x means cos of minus x. Now, we all of you know that cos of minus x, that is actually equals to cos of x. So, which is actually equals to f of x. So, your cos x, it is an even function. Now, similarly, you can check sec x. This is also an even function, and x square. This is also an even function. And what is the definition of odd function? So, a function f of x is said to be odd function if your f of minus x, which is actually minus of f of x. So if we take an example like tan x, so if it is tan x is equals to your f of x, now if you want to find minus f of minus x, that means tan of minus x. Now we know that tan x is actually minus sin x by cos of minus x. Now sin minus x, that will give you minus sin x, and cos minus x, that will give you cos x, which is actually equals to minus of tan x. So that is minus of f of x. So therefore, your f of x is equals to tan x. This is an odd function. Now similarly, you can say your sin x, this is also an odd function, and your x, only x, that is also an odd function. And if you draw the graph of a function, then what the graph of even function will be like this. If this is my x-axis and this is my y-axis, I am assuming this is my x-axis, this is my y-axis, and this is my 0. So suppose your function is like this for the positive x, then similarly for the negative x you will get like that. Okay, so that is what, if you take, if your y-axis is a mirror, your y-axis is working as a mirror. Now here you can see whatever the value of x, suppose this is value of x and this is positive value, and here it is negative value. Now for the positive value your y, and for the negative value your y is same. Okay, so f of x is equals to f of minus x. So this is your even function graph. Okay, and again, if you draw, this is my x-axis and this is my y-axis. Now if it is your x, so it will look like this. So here you can see, if it is in this, it is x, so this is your y-axis. So now you can say it is positive value x का, and it is your negative value x का. Now here you can see the value of y, it is downside negative, and here for value of y it is positive. So in that case, it is, you can say that your f of minus x is equals to minus of f of x. So this is the graphical or geometrical meaning of odd function. Now come to the Fourier H series expansion. So we know that a periodic function f of x, a periodic function f of x defined in minus c to c can be expressed as the Fourier series f of x is equals to a0 by t plus sum of n equals to 1 to infinity an cos n pi x by c plus sum of n equals to 1 to infinity bn sin n pi x by c, where your a0 will be calculated as 1 by c minus c to c f of x dx. an will be calculated as 1 by c minus c to c f of x cos n pi x by c into dx, and your bn will be calculated as 1 by c minus c to c f of x sin n pi x by c to dx. So this is my Fourier series expansion of a function. Now coming to the our part, that is case 1. If your f of x is an even function, okay, so if your f of x is even function, now when you calculate the a0, so that means a0 equals to 1 by c minus c to c f of x dx. Now you know by the property of integration, if your function is an even function, then instead of integration minus c to c, we can integrate 0 to c, and for that we will multiply it by 2. So therefore it will be 2 by c 0 to c integration 0 to c f of x dx. Okay. Similarly, if you calculate the an, so now an is equals to, your formula is 1 by c minus c to c f of x cos f by x by c into dx. Now come, so now you have to see this portion, this total function. So now your f of x is an even function, okay, f of x is an even function, and your cos n by x by c, this is also an even function. So f of x is your even function. So if I assume it is my capital F of x is equals to this. Now if you calculate f of minus x, so therefore it is f of minus x and cos of n pi minus x by c. Now f of x is an even function, so f of minus x will give you f of x, and we know cos minus x is equals to cos x, so therefore we can write it is n by x by c. So f of capital F of minus x is equals to capital F of x. So that means this is my even function. So now again we can use the property of integration, and if we use it, then it will be a n 2 by c 0 to c f of x cos n by x by c into dx. Okay. Now if you calculate the value bn, so what is bn? This is your 1 by c minus c to c f of x sin n by x by c into dx. Okay. Now again similarly, if we assume f of capital F of x is equals to f of x sin n by x by c, then you can see very easily that f of minus x is equals to minus f of x. So that means this function is your odd function. This function is the odd function. So on that case, if we use the property of integration, so it will be n is equals to 0. Okay. So therefore, if the given function is an even function, so if your periodic function f of x is even, if the periodic function is even, if a periodic function is even, then you have to calculate only a0 and an. The formula of a0 is 2 by c 0 to c f of x dx, and the formula of an is equals to 2 by c 0 to c f of x cos n by x by c into dx. And in this case, your Fourier series expansion will be f of x is equals to 0 by 2 plus sum of n equals to 1 to infinity a n cos n by x by c. Okay, so this is my Fourier series expansion for the even function. Now, similarly, for case 2, if your given function f of x is an odd function, then if it is odd function, then your a0 will be minus c to c f of x dx. Now f of x is odd, so this will be give you 0, and again an is equals to 1 by c minus c to c f of x cos n by x by c into dx. So in that case, the whole function, it is your odd function and this is your even function. So but the whole function will be odd. You can check it by the same way which I did earlier. So now since it is an odd function, the value of an will be 0. But if you find the value of Vn, so value of Vn is 1 by c minus c to c f of x sine n by x by c into dx. Now your f of x is an odd function. This is your odd function, and sine, this is also odd function. So together will be an even function. Now if we use the property of integration, so it will be 2 by c minus c to c f of x sine n by x by c into dx. Okay, so when your function is even the odd, so if your f of x is an odd function, then you need to calculate only bn, and that will be 2 by c 0 to c. So this will be 0 to c. Okay, 0 to c f of x sine n by x by c into dx, and where the Fourier series expansion will be f of x is equal to sum of n equals to 1 to infinity bn cos n by x by c to dx. Okay, so I hope all of you have understood when you will your given function is odd or when is your given function is even. So let's solve an example so it will be clear. The idea will be more clear by this example. Suppose your f of x is given x by 2, okay, and you have to express it as a Fourier series in the interval minus pi to pi. Okay, minus pi less than x less than pi. Okay, good. So now for solution, your f of x is given at x by 2. So now if you check f of minus x, so that means it is minus x by 2. So therefore minus f of x. So that means our given function is an odd function. Okay. So now given function is odd function. Now here you have to find the value of c. So here you can see the length of the interval is actually equals to 2 pi. So c is equals to my pi. So now this is your odd function. So now you can see the formula. When your f of x is odd, no need to calculate a0 an, you have to calculate only bn. So use the formula of bn. So what is the formula of bn? Bn is equals to 2 by c, that means pi. Now 0 to c, that means 0 to pi f of x into sine n pi x by pi. So pi will be cancelled. So that means you can write only n into x dx. So therefore it is your 2 by pi 0 to pi minus x into functional value of f of x is x by 2, and it is sine nx. So therefore you have to integrate 0 to pi x sine nx dx. Now if you integrate it, 1 by pi will goes outside, so it is x. Now integration of sine nx is cos, so minus n, then minus plus sine nx by n square, and it is 0 to pi. Now if you put the limit, so 1 by pi cos n pi by minus n. Now sine n pi will give you 0. Okay, and cos 0 into cos, so 0, and sine 0, so therefore it is only this one. So that means minus 1 by n, and value of cos implied it will give you minus 1 to the power n. So now the thing is, if you want to find b1, so b1 is minus 1 by 1 minus 1 to the power 1, so it will give you 1. Now b2, that means minus 1 by 2 into minus 1 to the power 2, so minus 1 by 2. Similarly, b3 will be 1 by 3, b4 will be minus 1 by 4. Okay, so therefore Fourier series expansion is x by 2 is equals to b1 sin x, nx means x plus b2 sin 2x plus b3 sin 3x plus dot dot dot. So you just put the value of b1, so it is 1, so that means sin x minus 1 by 2 sin 2x plus 1 by 3 sin 3x dot dot dot. Right? So this is my required answer. Now similarly I am giving you an example and I hope all of you can solve it. So just write the example. Find Fourier series expansion of x square in the interval minus L to L. So I hope all of you complete it. Okay, and please verify it. Your answer will be x square is equals to L square by 3 minus 4L square by pi square cos pi x by n by 1 square minus cos 2 pi x by n by 2 square plus cos 3 pi x by n by 3 square minus dot dot dot. So please check it. In the next class, we will discuss about our half range series. Thank you for watching.